Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering. This is the lecture for Civil 4th semester class. Subject is Concrete Technology, and today we are going to discuss the concrete mixed design procedure. In the previous video, I have explained you the steps which are involved in the mixed design. So today we will be going to discuss each and every step in detail and proceed with the concrete mixed design. So process of mixed design, as explained earlier, it includes 7 steps. So first is the target strength, the calculation of the target strength, then selection of water cement ratio, then selection of water content, then calculation of the cement contents, then proportion of volume of aggregate, which will be depending upon the size and zone of aggregate, then the mix calculation. In the mix calculation, we are calculating the mass of the fine and the coarse aggregate, and finally the mix proportion. We decide the mix proportion for the various mass which we calculate by the design procedure. So basically, mixed design, we are calculating the weight, the mass of the various material per cubic meter. So per cubic meter mass of cement, fine aggregate and coarse aggregate, and the water content which is required per cubic meter, that will be that we will be calculating. So students, in specifying a particular grade of concrete, the following information shall be included. First is type of mix, that is design mix concrete or nominal mix concrete. Before going with the design of the concrete mix, we need to know, we need to have specific information about that particular concrete. Initially, which type of mix it is, either we are designing the mix or we are taking the nominal mix. Then grade designation. If we are designing the mix, then we should be clear about the grade of that particular concrete, which concrete we are going to design. Then type of cement, which type of cement is used, that we should know, either it is a PPC, either it is a OPC, which grade of cement we are using, which company of the cement which we are using. So we should know this information before going for the mixed design. The next is the maximum nominal size of aggregate. So we should know the maximum nominal size of aggregate which is being used and for which we are designing the concrete. And then minimum cement content for design mix concrete. If we are designing the concrete, earlier also I have told you कि design mix basically it includes the testing of the materials before going for the design procedure. So we need to test the materials, we need to check the nominal sizes of the aggregate, we need to calculate the minimum cement content, we need to follow the Indian standard codes for the mixed design, which is IS 456 and IS 10262, as explained in the last lectures. Then maximum water cement ratio, we should know, we should have the information how much maximum quantity of water cement ratio we need to fix. Then workability, workability basically how much workable we need our mix to be. For example, it may be for the 100 slump, or for 50 slump, or for 75 slump value. So then mix proportion, if we are going for the nominal mix concrete, then we should know the mix proportion. Then exposure conditions as per table 4 and 5. So exposure conditions basically refers to the mild conditions, severe conditions, moderate conditions, and so on, which we will be discussing in this video, then maximum temperature of concrete at the time of placing, methods of placing, and degree of supervision. So basically, these are some of the informations which are required before going for any mixed design. So students, now we will discuss step by step procedure in detail, which includes your mixed design. So mixed design calculation for M20 concrete. We will be taking grade of concrete which is M20, and we will be discussing the step by step procedure in detail. So the information which we are having for this M20 grade of concrete, that is maximum size of aggregate which is used is 20 mm, then degree of workability 0.80 compaction factor. So degree of workability, if we are talking of degree of workability, that means we are talking in terms of the compaction factor. So it is 0.80. So it may be assumed that the slump value which will be required for this particular mixed design, it will be 50 mm. So degree of quality control, it is good. Then type of exposure, mild. Water cement ratio 0.47. Cement used, it will be ordinary Portland cement 53 grade. Then specific gravity of cement 3.15, specific gravity of coarse aggregate 2.70, specific gravity of fine aggregate 2.65. Then water absorption for the coarse as well as the fine aggregates, which is 0.5 and 1% respectively. Free moisture content. Free moisture content in coarse as well as fine aggregate is taken 0%. Then bulk density of cement, coarse aggregate and fine aggregate 1440, 1650 and 1800 kg per meter cube respectively. So students, before going for the mixed design, we need to conduct the laboratory testing on the material, and we need this information as discussed earlier for the mixed design. So considering these information, considering these parameters, we will start with the mixed design. So first step is the target strength. So target strength, it is equal to FCK plus 1.65 multiplied by S. So target strength, it is equal to the characteristic strength plus 1.65 into standard deviation. We are going for the design of M20. So this means our characteristic strength is 20, and for M20 you will refer to the table 8, right, of IS 456. Corresponding to this M20, we are having the value of assumed standard deviation, which is our S value in Newton per mm square. So it is 4. So for M20, M25 value is 4. From M30 to M50 value is 5. For M10 and N15 value is 3.5. So correspondingly, we are taking the value 4. So 20 plus 1.65 multiplied by 4, it becomes 26.6 MPa. That is Newton per mm square. So students, we are going for the design of M20. 20 is your characteristic strength at 28 days of curing in Newton per mm square. So that is not our target strength. If we are going for the design of M20, our target strength will be 26.6 Newton per mm square. So standard deviation we will use from this table 8, and we will calculate our target strength. So students, this was the first step, the calculation of the target strength. Next step, it includes the selection of water cement ratio. So for mild exposure, as in the example we have taken the mild exposure condition, the maximum nominal size of aggregate 20 mm. So basically for the maximum nominal size of aggregate 20 mm and for the mild exposure condition, we will refer this table 5 from IS 456 2000 and we will decide the water cement ratio. So you can see this table 5. It is not clear over here. I will show you just now. So table 5, it is the minimum cement content, maximum water cement ratio and minimum grade of concrete for different exposures with normal weight aggregates of 20 mm nominal maximum size. So for 20 mm nominal maximum size, which is our uh, specified size of the aggregate in the example, and for the mild condition we will use this table. So you can see this exposure conditions: mild, moderate, severe, very severe and extreme. So this is for the plain cement concrete, this is for the reinforced cement concrete. So basically we are discussing the reinforced cement concrete. So here it is the minimum cement content kg per meter cube, and then maximum free water cement ratio and minimum grade of the concrete. So for M20 and mild exposure condition and for 20 mm aggregate size, the maximum free water cement ratio is 0.55. So students, just see this slide. Water cement ratio 0.55. So adopted water cement ratio, it is equal to 0.47. Students, we have been given in the question, in the example, we have to adopt the water cement ratio of 0.47, or we can take water cement ratio 0.47. So you can see this question, water cement ratio, it is 0.47. So we have checked the water cement ratio from this table. Maximum free water cement ratio, it should be 0.55, not more than 0.455. Then as per the question, we are having 0.47, which is less than 0.55, hence it is okay. So we will be taking this 0.47. This 0.47 water cement ratio for M20 grade of concrete for mild exposure condition and for 20 mm aggregate size, it is okay. So if the water cement ratio, it is not given in the statement or in the question, then you can take any value below 0.55. It may be 0.40, 44, 46 or 0.50. So any value you can take. So this is your second step, selection of water cement ratio, which will be based upon the table 5 of IS 456 2000. Then next is selection of the water content. Now you can see this table, which is again taken from IS 10262 2009. This is the table 2, maximum water content per cubic meter of concrete for nominal maximum size of aggregate. So corresponding to the nominal maximum size of aggregate, the maximum water content is mentioned for 10 mm 208 kg per cubic meter, for 20 mm 186 and for 40 mm 165 kg per cubic meter of concrete. So using this table, we will select the water content. So as per our question, we are having the 20 mm nominal size aggregate. So maximum water content, it is 186 liters. So we can take the water content as 186 liters. Next step is the calculation of the cement content. So water cement ratio taken for our M20 grade of concrete, it is 0.47. Water cement ratio, that means water to the cement content, it is 0.47. Then from here, water content we have already determined, which is 186 liters. So cement content we can calculate by water content divided by 0.47. So it is 395.75 kg per meter cube. So this is the calculation of the cement content. Again, you have to check the calculation of the cement content. So table 5, which is this table. So you will check your calculated cement content. Minimum cement content, it should be 300 kg per meter cube. So your calculated cement content, this should not be more than, this should not be less than 395.75 kg per meter cube. So the value, it should not be less than 300. So basically you will calculate the cement content, then you will compare it with the table 5, and it should fulfill the minimum requirement of the cement calculation. So the calculated cement content is 395.75 kg per cubic meter, and this is okay because the minimum required was 300. So if it may be 295, then we should take the cement content as 300 kg per cubic meter, right? So students, we will continue with the other steps in the next video. Thank you.